y-intercepts are where they cross the axes. So the x-intercept is where it crosses the x-axis. How we solve for them is set y equal to 0 and solve for x. So, for example, this one hits 3 times, so there are 3 x-intercepts. The y-intercept is where it crosses the y-axis, so we set x equal to 0 and solve for y. On this graph we have 2 y-intercepts. So we want to find the intercepts of y equals x squared plus 4x plus 3. So for the x-intercepts, we set y equal to 0 and solve for x. So it's a quadratic. We can factor this to x plus 3 times x plus 1. And we get our two answers. X is -3 and -1. For the y-intercept, we set x equal to 0 and solve for, we set x equal to 0, now we solve for y, so y equals 3. An equation of a circle has center hk and a radius r. It takes the form quantity x minus h squared plus y minus k squared equals r squared. This is the standard form for the equation of the circle, and if the center of the circle is at the origin 0, 0, it takes the equation x squared plus y squared equals r squared. So we're going to graph y squared plus x squared plus y squared equals 16. Because there's no k or h, our center is at 0, 0, the origin. And r squared equals 16, but we want just r, so we square root it. We get r to be 4. So we count out 4 from the origin. We go to the right, 1, 2, 3, 4. We go up, 4, left 4, and down 4. And we connect it with the curve to create our circle. And hopefully yours is better than mine. The airliner is very difficult to make a circle on. If you do have a K and an H, you need to take out those values. Remember, it goes x minus h quantity squared plus y minus k quantity squared equals r squared. So h is 3, k is -2, r squared equals 25, so r is 5. So we put h and k together for our center, 3, -2. And then we go 5 up, down, left, right from the center, so we can draw our circle. we're going to find an equation of the circle with radius 4 and center -6, 2. We're going to plug this into our equation. X minus h squared plus y minus k squared equals r squared. So we have r, we need r squared. So we square both sides and get 16. H is -6. K is 2. And we plug it in. X minus -6 squared plus y minus 2 squared equals 16. Just change minus negative to a positive. We'll now be finding an equation of the circle that has endpoints P at 2, 7 and Q at its -9. Because they're endpoints, if we connect them, that makes it a diameter. Because it's a diameter, we can find the midpoint, which is also the center of the circle. So we use our midpoint formula. 2 plus 6 over 2, 7 minus 9 over 2. So our center, which is also the midpoint, is 4, -1. So that is our h and k. We now need to find the radius. And to do so, we're just going to find the distance between the center and one of the 2 points. So we are going to use our 2 points, 4, -1, and 2, 7, and plug it into the distance formula. So it goes down to the square root of -2 squared plus 8 squared. -2 squared is 4. 8 squared is 64. 4 plus 64 is 68. So our radius is root 68. So now we have everything we need. Plug it into the equation for a circle. We get x minus h, which is 4, quantity squared, plus y plus 1, quantity squared equals root 68. Let's talk about some symmetry. Symmetry with respect to the x-axis. Under symmetry with respect to the x-axis, that means the graph is unchanged when reflected over the x-axis. So here's our x-axis. We have a point xy above. If we go below the x-axis, the point would be x -y. With symmetry with respect to the y-axis, that means the graph is unchanged when reflected in the y-axis. So a good example would be a parabola. It has its axis of symmetry as the y-axis. So we would have the point negative xy and the point xy. And if there's symmetry with respect to the origin, the graph is unchanged when rotated 180 degrees about the origin. So we would rotate it about the origin, and they would be the same. We will cover graphing using symmetry in class tomorrow.